All right, guys. Normally, we would have the day today to work on the review sheet, but we're going to go on and start going over it because I want to get enough time to actually go through everything. Yes. Yes. There should be. Yep. So the first 12 problems are factoring. We're factoring them. I'm going to go on and look at just problem one unless there's a specific one y'all want to look at. So looking at one, factoring, there are several steps. I did write them on the whiteboard. The first step in factoring is greatest common factor. We're always looking for a greatest common factor, something that can go into every term. And here, the greatest common factor is 7. So we're going to divide each term by 7 and put the 7 out front. So when we take 7 out of 7b squared, we have b squared. When we take 7 out of 63, we have 9b. And when we take 7 out of 140, we have 20. Since we factored the 7 out, we can move on to step number 2. Our 2 sets of parentheses with 3 spaces, which actually takes care of step number 2. Step number 3 is to find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Here, the third term is positive, so our signs are the same and match the sign of the middle term. Negative. So we have negative and negative. Takes us, yes, sir.
So if it's negative and positive, it'd be negative and negative?
If the third term is negative, the signs are opposite.
All right. I was doing my homework last night and I didn't understand it.
If the third term is positive, the signs are the same and match the sign of the middle term. So the only time we look at the sign of the middle term is if the third term is positive. If the third term is negative, our signs are opposite. We don't even look at it if the third term is negative. Step 3 is factors of the first and third term. Factors of our first term, b squared, b and b. That's the only way we get b squared, is b times b. And this works. 20, on the other hand, has a few. We have 1 and 20. 4 and 5. 3 doesn't work. 4 and 5, well, the next factor after 4 is 5. It's already listed. We're done. So we can pick 4 and 5. Because again, we find the factors of the first and third term and plug them in. Now, the last step is to check. And we're trying to get it to be the middle term. B times negative 5 is negative 5b. Negative 4 times b is negative 4b. Negative 5b minus 4b is? So these are our factors.
Yes, sir.
Looking for a review sheet? Hunter? Looking for...
No, I was looking for a homework one.
Okay. If it's not up there, Google Classroom will have it.
All right, can I on just regular?
Yeah.
Thank you.
You're welcome. Questions with factoring. Questions these here.
Can we do number 11?
Yes. We'll go back to some of the perfect squares so we see those again too. A squared minus 28a plus 196. Again, first step, greatest common factor. Is there one? No. And I didn't say this first time we went through, but one of the big giveaways is what's the number in front of a squared? 1, yes? There's nothing we can take out of it because 1 doesn't factor. Factoring out 1 doesn't change anything, but if that's the only factors, there's no way it's going to have anything in common with the rest. So we can move on to step 2. 2 sets of parentheses with 3 spaces. Signs. If the third term is positive, the signs are the same and match the sign of the middle term.
So it's negative.
And if the third term's negative, the signs are opposite. Well, it's positive, so the signs are the same and match the sign of the middle term. So we have negative and negative. Well, luckily for us, factors of a squared are a and a. If there's only one set of factors, just go on and plug them in. Go on and plug them in. We can check to make sure we set it up correctly in a minute. 196. Well, we have 1 and 196. We have 2 and 98. 3 is not a factor of 196, because if we add the digits together, 1 plus 9 is 10, plus 6 is 16. 16 is not divisible by 3, so 196 is not divisible by 3 either. 4 and 49. 5 is not divisible by 196 because it doesn't end in 0 or 5. 6 is not divisible by 196 because 2 and 3 have to be. 7. Okay. 196 divided by 7, 28. So 7 and 28. 8. So the next one's 14 and 14. Now, since we're just factoring, we're not solving, when we check, we can check it underneath it. I normally wouldn't put it there if we're solving because we do have steps after this. But if we check this here, a times negative 14 is negative 14a. Negative 14 times a is negative 14a, which gives us negative 28a. Is that what we wanted? So this here is the correct answer. Now, I could have also written this as a minus 14 squared, because both factors are a minus 14, yes? So we can rewrite it as a single term squared. I don't care if you leave it as a minus 14 times a minus 14 or write it as a minus 14 squared. It is the same answer. Questions on this here? Let's take a step back and let's look at these here. Let's look at number 9. 196x squared minus 144. Well, we just encountered 196, yes? And we know that it is a perfect square because if we can factor this, this has to be set up as a difference of perfect squares. So we know 196 is these 196x squared is a perfect square because we can say 14x times 14x or 14x in parentheses squared. 144 is 12. And so this is our difference of perfect squares, which in the general form is our a squared minus b squared is equal to a plus b times a minus b. So we will have our plus and minus. Now the a in our case would be 14, what? 14x. So we have 14x and 14x. The 144 would be our 12 and 12. Now we can check this here and make sure it works. 14x times negative 12 is, well, for sake of time, 168. So we have negative 168x. 12 times 14x is plus 168x, which is 0, which is the middle term we want because we don't have one, so we need the middle term to be 0. Before we finish this one up, 14x minus 12, is their greatest common factor? Is it 2? Yes? So I can factor a 2 out of that. 14x divided by 2 is 7x. 12 divided by 2 is 6. How about the other one? So we have another factor of 2, yes? So when I factor this out, we have 7x minus 6. Our 2 times 2 is, so this here is completely factored, but that is factored. I will take either of these here. Okay? So factored, if you notice that the original did have a common factor of 4, you could have factored it out. It would have given us 49x squared minus 36, which would have factored x, or 7x plus 6 times 7x minus 6 with our 4 in front. Either one works. Questions on this here? Questions on our difference of perfect squares? Well, if we look at the next one, it is a difference of perfect squares, because what times itself is a squared? A and A, yes? What times itself is 25b squared? Yes? Because we'd have 5 and 5, and we'd also have b and b. So it'd be a plus 5b times a minus 5b, difference of perfect squares. Questions on this here?
So is that's how you do that one?
Yeah, because it's a less stepped out version than the last one, but it is the same thing. Questions on these here? Any questions on factoring? We feel good with factoring? On a side note, would y'all want me to go back through and do a video with all of these? Okay.
Yes.
I will do that. I will get that posted later tonight. Okay? It might be at a decent speed, but again, pause if you ever need a pause, especially in the videos. But let's look at these here. I really hope that these, because I am putting these on the test, that you get all of these right. I'm going to look at the first one, 64 squared minus 25 squared.
Is that it?
That is it. Because, I mean, we went through the original method is because it is a difference of perfect squares. We could have written it as, I will write this out, you don't have to write this, as 64 minus 25 times 64 plus 25. And for most of us, we would then go grab the calculator, do 64 minus 25, and get 39. 64 plus 25 is 89. Then we'd again plug it in the calculator, and we should get 3,471. Well, heck, we most likely plugged the thing in the calculator 3 different times. Once to get the 39, once to get the 89, and then once to multiply the 2 together. Plug the whole thing in. 441 minus 361. Minus 361. 64,160. That is it. Questions on this here? Yes. Any other questions on 15 and 16?
Best thing in Algebra 2 ever.
17 through 23. Solve each equation by any means. The first way we went over solving was by factoring. The second was graphing. The third method was, not completing the square. Okay. The third method was square root method. The fourth method was completing the square. And the last method was quadratic formula. We have these 5 methods to solve. There will be certain sections on the test that are going to be specific about how they want you to solve it. If it says by graphing, I want you to solve it by graphing, which most likely is just going to be plugging in the calculator, you give me the answers, that's it. If it says factoring, I am going to be looking for the factoring step that you factor the polynomial and solve it that way. Or there's not one that specifically says square root method, but there are 2 for completing the square. There are 2 for quadratic formula. If you do get stuck on, say, completing the square, and you are comfortable with quadratic formula, go on and solve it by the quadratic formula. Get the correct answers. You will lose the point or 2 or the points associated by doing it by the correct method, but it's still better to get the correct answers and earn those points than to forfeit all points entirely. Does that make sense? So when it says by any method, it means we can pick any of those to do it by. So if we look at the first one, x squared plus 3x plus 2. If I want to, clear all that out, x squared plus 3x plus 2. Graph, we get this here. Yes? Crosses at 2 places. And we solve by graphing. We're looking for what values of x will make the y value be 0. So our 2 solutions are and if this was the section to solve by graphing, that's all we need. Because I'm not going to have you call me over to make and show me the calculator that shows that you've solved it by graphing. I'm going to assume that if you just have this, you've solved it by graphing. Questions on this here? X squared minus 9. I would do this by the square root method because we have no middle term. We have no x to the first. Square root method says we get the squared term by itself first. So we can add 9 to both sides, telling us that x squared is equal to 9. Once we get the squared term by itself, we take the square root of both sides. That's where the square root method gets its name, because the square root of x squared is x. And this is halfway right. There is one thing we're missing, plus or minus. That is going to be one place that most are going to lose points, is if you take the square root of both sides, you have to include the plus or minus. If you take the square root of both sides, you have to include the plus or minus. Because positive 3 and negative 3 work for this here. If I were to graph it, x squared minus 9 graph, it intersects at 2 places, at negative 3 and 3. Both of those work. If you give me one, as I said earlier, you're halfway right. You got half of the correct answers. You're missing the other half. Questions on this here? $19. Anyway about it, I'm going to get this thing equal to 0. 1/5 x squared minus 2x plus 6 equals 0. Since it doesn't tell me how I need to solve it, I normally stick with graphing. X squared is minus 2x plus 6. Graph. Well, doesn't cross the x-axis. Well, that's actually one of the homework problems from 3.3 when we were solving by graphing. And at this point, especially in the homework, we said it was no real solutions. And the reason we said no real solutions is it doesn't cross the x-axis, and we had no idea about I. I wasn't a thing yet. At least we haven't covered it yet. But we can still solve this. Because now we do know about I, our imaginary terms, which means this thing here has two imaginary solutions. Now the biggest issue, and I think what most of y'all don't want to worry about or kind of mess with this with, is the 1/5. Yes? What can I multiply 1/5 by to make it be 1? 5, yes? There is nothing that says I cannot multiply both sides of this equation by 5. It'll give us the exact same thing. And the reason I would do this is because 5 times 1/5, x squared is just x squared. Like when we divided by -1 to get it to work better with solving, same thing as with 5. 5 times -2x is -10x. 5 times 6 is plus 30 is equal to 0. So we multiplied by that 5 to make the numbers be nicer. Now, because we know it didn't cross the x-axis, that eliminated 3 of our possible solutions, or not solutions, but solving methods. It eliminated factoring, graphing, and square root method. Kind of square root method. And left us with completing the square and quadratic formula. Square root method's kind of yes and no, because we technically use the square root method in completing the square. Kind of tongue-in-cheek there. But here, A is 1, B is -10, C is 30. So when we plug this in, we have -b. So it'd be -10, plus or minus the square root of b squared minus 4 times A times C all over 2 times A. So again, we take the values of A, B, and C and plug them into their respective places. Question? Because it doesn't cross the x-axis, so it's not going to give us any points on it. Because if the solution comes up with I as part of the solution, it won't cross the x-axis. And the quadratic formula and completing the square are the only 2 methods that will actually give us the solution every time. So they're the ones we have to fall back to for this here. Now, on the test, when it asks for you to solve it by factoring, they're going to be factorable. When it tells you to solve by graphing, you are going to be able to graph it. The only places where I and these non-simplifiable radicals will show up are when it asks for completing the square or quadratic formula, because those are the only 2 that have it. Now, I did do some simplifying while I was talking. Our -10 becomes +10. Our 2 times 1 is 2. -10 squared minus 4 times 1 times 30. Now I'm going to plug everything inside the radical in the calculator first. -10 squared minus 4 times 1 times 30 is -20. Well, we have to simplify that radical first. Now, square root of -20. The 30xs, the yellow calculator will simplify radicals. It will not simplify negatives. But the negative comes out as I. Now the yellow calculator will take the square root of 20, which is 2 square root of 5. So the square root of negative 20 is 2i square root of 5. I will take this as the final answer here. If you can at least get it to here, that's as far as I want you to go. If you are able to see that there is a common factor of 2 in both, our 10 divided by 2 would be 5. Our 2i divided by 2 is just I. Square root of 5, I will take that 2. I will take either one of these here. I will count off points if you leave a negative inside of a radical, or whatever that radical is reducible. So if the final spot was, say, the square root of 13 is what we had in there, square root of 13 won't reduce, that's fine. Square root of 20 is 2 square roots of 5. I want you to reduce that. I am not going to count off if you don't get it all the way down to here. Does that make sense? Do we understand the difference between those two? Because I want you to simplify the radical from square root of negative 22 to 2i squared of 5. That I do want you to do if you can simplify that radical. I'm not asking you to make sure that it doesn't have any common factors on top and bottom. Any other questions on this one here? Okay. Questions on this here? Okay. Questions on 20? Probably questions later. I will come back to those if we do have more questions on them later, because I do want to start some of these here. Solve each of the equations by using completing the square method, the completing the square method. So I do have the completing the square method steps written on the whiteboard. I would advise writing them down at least somewhere on that page. And luckily, completing the square does not take the full page. I gave you the full page, and I will give you a full page on the test for the two problems, kind of like this here, so that you have the space if you need the space, just in case. Now, completing the square. Step number 1, is A equal to 1? If not, make it so. So if we look at 24, is A equal to 1? No. So to make it so, we're dividing everything by 2. And we divide everything by 2. 2x squared divided by 2 is x squared. Negative 12x divided by 2 is negative 6x. Negative 24 divided by 2 is negative 12. Is equal to 0. X squared minus 6x minus 12 equals 0. Okay, good. Takes care of step 1. Step 2, get the variables by themselves. All that means is that we have x squared and negative 6x on one side, or 12 we need to get on the other. And we also are going to leave 2 spaces. So we're going to add 12 to both sides. So I'm going to say we have x squared minus 6x plus blank is equal to 12 plus blank. Questions about steps 1 or 2? So step 1 is A equal to 1. If not, make it so. Step 2, get the variables by themselves. So we get the x squared and negative 6x in this case on one side. And we move the 12 to the other side. Step 3, find the value of c. Because what we're wanting to do with completing the square is to turn our x squared minus 6x into a perfect square trinomial. So we can rewrite it as a set of parentheses, squared. And to get that third term, we're going to use c is equal to b over 2 squared, where our value b in this case is negative 6. if it is helpful, I would write somewhere our ax squared plus bx plus c is equal to 0, just as a reminder for where a, b, and c are. A is the number in front of x squared, b is the number in front of x, and c is our constant term. At this point here, our -6 divided by 2 is -3. And -3 squared is 9. So what we're adding to both sides of the equation is 9. Because our x squared minus 6x plus 9 is a perfect square trinomial. Question? -6 over 2. Right here. B over 2. Yeah, C equals B over 2 squared. So that's our just set formula. And the reason we did all this was so that the left-hand side, our x squared minus 6x plus 9, will turn into a set of parentheses squared. Now we will have x inside those parentheses. Okay. So we have x. Now the number and sign that go with it inside that parentheses is whatever the number and sign of that we had before we squared it. So -3. So it becomes x minus 3 squared. Questions on this here. Now the other side, 12 plus 9 is 21. Well, get another color. So we're trying to factor this here. And it works out that the number that goes in there is the number we had inside the parentheses before we squared it in finding C. It's kind of the shortcut method for factoring. Huh? Yeah. Now, at this point here, we're going to take the square root of both sides. Here, the square root and square will cancel, telling us that x minus 3 is equal to, again, anytime we take the square root of both sides, plus or minus. Now, again, square root of 21, we do need to make sure if it simplifies, we will simplify it. 30xs will tell you if it simplifies or not. And it does not. If it gives you the same radical back, what it's telling you is that the square root of 21 is already in simplest radical form. We leave it as the square root of 21. And the last step, because we factored and solved, we just need to get x by itself. So we will add 3, telling us x is equal to 3 plus or minus the square root of 21. Questions on this here? Okay. Any questions on anything we've done so far? All right. You, sir, are in the wrong spot. But we'll finish with this one here. This one here I added to the review sheet because there is going to be at least one of these like this exact problem on the test, and it's going to ask you to solve by factoring. Is it already factored? Yeah. And I left it off the previous review sheets because I hoped we would see that it is factored and we can just solve, but it turns out I've been wrong. So I want to go through this here. Because when we solve by factoring, we rewrite it as 2 sets of parentheses being multiplied together. That's what factoring is. And according to our zero product property, whenever we have 2 or more things multiplied together to equal 0, one of them must be. So this is saying that 2x minus 7 is equal to 0. Or 5x plus 13 is equal to 0. They're already factored. Set either one of them, set both of them equal to 0, and solve. So here we would add 7x to both sides. Or not 7x, 7. We add 7 to both sides. Minus 2x equals 7. Then we would 7/2. I mean, if it was 8/2, we would simplify, but 7/2, we can leave it as that. So I can plug it in the calculator, say 7 over 2 is 7/2. Need to solve the other one, we would subtract 13. Telling us 5x equals negative 13. Indeed, we would divide by 5. Telling us x is negative 13 over. If it's already written as two sets of parentheses being multiplied together, and it tells us to solve by factoring, set them equal to 0, solve. That's it. Questions on this here? Any questions on anything we've done so far? Where this way? Not technically, but if we go back to the first one, if we said this was equal to 0, we would do these same steps. Well, instead of being done at this point, it's equal to 0. I have 2 or more things multiplied together equals 0. One of them must be 0. Add 4, telling me B is 4. Yes. Yes.